Hey everybody, my name is Dr. Justin Bailey, and I thought I would share some fun statistics. I know that's an oxymoron, and most people are not a big fan of numbers and math, but there are some things about statistics that I thought were important to know, particularly if you want to apply critical thinking to some of the headlines you might hear when they involve graphs or numbers. Part one is called emotional numbers. I've broken this up into three different parts, hopefully to make it a little more manageable. But emotional numbers, what's that? Well, graphs do evoke emotions from people. The way we present numbers definitely is sometimes geared to try to affect people's emotions. So I want you to be aware of that and to maybe dig a little deeper. Here is an example. I came across this graph that said, and the headline was, "Women want to work from home more than men." And as you can see, the graph on the right is huge, this big bar. Makes it seem like women are 3, 4 times more likely to want to work from home than men. But if you look over to the left, you'll see that the lowest percent here is 76. So 79 to 85. Well, let's look at this a little differently. What if we made this from 0 to 100? You can see that men do want to work from home a little less than women, but I would say the headline should be workers prefer to work from home, right? 4 out of 5, either gender. And again, this graph makes it seem like women are way, way more interested in working from home. But this graph, wouldn't be the take home message or the headline that I might give from this statistic. So every statistic you see tells a story, right? And it gives an impression and makes you think certain things. So here's an example of two separate headlines. One is the percentage of adults with a high school diploma hasn't increased in a half century. Oh my gosh, so the statistic tells a story of the lack of educational advancement here in America. But the very next statistic is also true. The percentage of adults with a college degree has doubled since the 1960s. Wow! Makes it seem like there's been educational advancement. Well, this is the graph that both these statistics come from. And it shows that, yes, there has not been any growth. This is high school diplomas. By the way, this is the year they were born. So really, this is like 1970, late 60s. We kind of hit a ceiling. In fact, this is called the ceiling effect. Once you kind of get real close to the ceiling, you might not be able to increase the number of people who get a high school diploma by much more. Maybe we can improve it a little bit. There's always going to be people who don't get a degree. They don't need one. They get a job before they graduate. Maybe they've got a disability. Lots of reasons why adults don't have a high school diploma, and so maybe we're pretty close to that ceiling. On the other hand, the percentage of people down at the bottom, this is men and women with college degrees. Again, this is their birth year, so they graduated from college around the 1970s. You can see that we're now at mid 30s percentage wise. Well, that's double what it was 50 years before that at 16, say 16 to 32. So doubling sounds like a lot, but really there's a huge number of people who could still get a college degree. In fact, what we call this is the basement effect. So all this to say that this graph shows progress, mostly in the early mid 1900s, and the college diplomas has sort of leveled out, and we're now increasing that a little bit more. But you get the idea that you can't ever say doubling. In fact, once you get past 50% of something, there's no way you can get double the amount. We'll never double the number of people with a high school diploma as a percentage, but we still could double from 36 up to 72%. So how is this in the real world? Well, I keep coming across data. This is Our World in Data is an interesting site. And you can see kind of the same problem where you might hear things like, well, Australia doubled the number of people who were vaccinated between August and, I don't know, September. That sounds awesome, right? But we'll never double the number of people in the United States once we hit 50%. So we've only gone up 5% in the month. 10%, I guess, from 50 to 55 is 10% increase, whereas Australia went up 100%. In India, they doubled from 5% to 10% in a couple months, and I'm probably going to double it again in a month or two. So when you hear doubling, remember that basement effect, that when you start with a very low number, it's kind of easy to go from 2% to 4% as a doubling, but relative to, the top of the graph, the ceiling of a graph, that may or may not be a lot. Just something to consider. The other thing about statistics is they sometimes have this feeling of inevitability. And I had a student come to me and say, Dr. Bailey, I think I may become suicidal. And that got me worried as a therapist. I took the student aside and basically said, let's do a suicide assessment with this person. And after a little bit, it became clear they weren't currently suicidal. They didn't even have depression, but they had read this statistic. She said, in our textbook, Dr. Bailey, it says people with parents with depression, if both parents have depression, they're 13 times as likely to commit suicide. So she felt like it's inevitable. I will eventually get depression and maybe even commit suicide. I looked up the actual data this came from, and it is true. You're 13 times more likely to commit suicide. You're 0.39% versus if you don't have both parents with depression, you're 0.03% likely to commit suicide. Another way to think of this, by the way, is the likelihood of not committing suicide is 99.41% versus 99.97%. Most people do not commit suicide, but when put this way, it doesn't seem like a 13 times type issue. So I think that feeling of inevitability, whenever we hear something is like multiple times more, X is bigger than Y, a 600% increase, these types of things give us emotions, and sometimes we conclude there's not much we can do about it. So I thought that was an interesting example. All right, trigger alert for math, and maybe for coronavirus too. But just thought I'd come up with hypothetical virus X. Right, I'm not necessarily talking about coronavirus, but if you came across the headline that said half of the people in the hospital for a virus have been vaccinated for that virus, you might think, well, why should I bother getting vaccinated? I got a 50-50 chance of ending up in the hospital. Well, here's an example of why that might not be true. Again, this statistic could be true, the headline could be true, but these other facts might be true at the same time. 90% of the population is vaccinated. The unvaccinated are 50% more likely to get the virus, and the unvaccinated are 600 times more likely to be hospitalized. All of these things could be true all at the same time, and you want to dig a little bit and figure out, well, why could that be? Vaccine works, right? It cuts the chance that you'll get the virus, and it really cuts the chance that you'll be hospitalized for the virus. But yet, when you hear this statistic, half the people in the hospital have already been vaccinated. A lot of people read this and think it's inevitable. I might as well, I got a 50-50 chance. Well, again, I apologize for the numbers, but here's how that might break down. Let's imagine we've got a million people and 90% of them are vaccinated. So what percent? 90% of a million, we've got 900,000 vaccinated, where we have 10%, 100,000 out of this million is unvaccinated. We just, I'm arbitrarily saying that 50% of both groups, right? And they just in real life, the virus happens to be around. So 50% of both groups are exposed to the virus. So there's your numbers of 50%, half of this 900,000 and half of the 100,000 get exposed, right? So how many of them actually get it? Well, remember, you can still get the virus if you are vaccinated, but your chances are much lower. In fact, this is a 50% increase if you're unvaccinated, right? Half of 24 is 12, 50% of 24 added to this. That means this is a 50% increase in getting the actual virus after exposure. Well, what does that mean? That means 108,000 of the vaccinated group end up testing positive, and 18,000 out of this group test positive. We'll go a step further and say, well, what are your chances of getting hospitalized? Well, the vaccinated group is much less likely to get hospitalized. In fact, this is a 600% increase. 2% up to 12% is 600% more likely to get hospitalized. But you still could be hospitalized with the vaccine. Well, let's look at what happens when we do the numbers. Oh my gosh, we have the exact same number. Notice that 2,000 is a very small percentage of 900,000, but since there are more people vaccinated, most people are vaccinated, when you do this statistical analysis, you end up with about the same number of people in the hospital. Again, this is 2% of 100,000. This is 0.5% or something, right? 0.2%. So you're much less likely percentage-wise, but if you saw the headline and it just said half the people in the hospital have been vaccinated, you think, oh, the vaccine doesn't work. Well, here's what's interesting. Let's bump this up to 95%. I won't go through all of the statistics, but if you increase the number of people who are vaccinated, you increase this number, decrease this number, and you actually end up with more people in the hospital, even though we saved maybe close to 1,000 people from being in the hospital total, right? If we go back to the 90%, you see that we had about 4,300 people total in the hospital. If we increase the vaccination rate, we lower the total number of people in the hospital by 900. But again, the hospital would actually have a higher percentage of people who have been vaccinated. So I hope that helps. You can hear some of the politics going on where people will say a headline to try to get people to say, well, don't bother with the vaccine, or they don't work. Numbers are hard, and that's sort of my main message for all of this. So the emotional number part one takeaway message is to try to have some critical thinking when you see numbers. Question your emotions. Why are you having an emotional reaction? Why are the people trying to convince you to have an emotional reaction? Question the numbers, maybe reframe them, maybe graph them, change how it looks, and obviously try to question that source. Like, who are they? What are they trying to do? Maybe they've got a political bent. Maybe they want to seem like men and women are very different. Whatever it is who is telling you the headline, and what reaction do they want to have. All right, thanks. This is it for part one. I look forward to talking to you guys with part two. Thanks, guys.